A very good morning to all. Now, in the previous class, we had studied acceleration. Now, again, using acceleration, we are going to study about another physical quantity, that is force. So, now we will study what exactly force is. An example, take a glass marble and let it roll on a big smooth table. After some time, its velocity will decrease and it will stop. On a carom board too, the carom coin pushed by the striker will move forward some distance and then come to stop. If a coin is pushed after applying talcum powder to carom board, it will keep moving for a longer time and then come to a stop. What can we infer from this? We conclude that the velocity of a coin decreases due to force of friction and the coin stops. If the friction between the carom board and the coin is reduced, the coin keeps moving for a longer time. It would mean that if no force of friction is acting on a moving body, it will keep on moving with a constant velocity. That means the velocity will never change. Continuously the same velocity the marble moves. The scientist Sir Isaac Newton was the first to study force and the resulting acceleration. Newton's first law of motion. If no force is acting on a body, its velocity does not change, that is, the body does not accelerate. The object you keep will remain in its position, will not have change in velocity unless and until a force is acted to accelerate it. In other words, if a body is stationary, it will remain stationary, that is, in a position of rest. If it is in motion, it will continue moving with the same velocity and in the same direction. So, Newton's first law. Suppose now we throw a ball in the air. When we throw a ball in the air, after reaching at a certain height, it comes down to the ground again. If you bring a chair towards yourself, if you move the table in a class to one corner, fetch a bucket full of water from a tank, all these are what do we infer from the picture? Now we have seen that a body is accelerated due to force. Like the examples we shown, they are examples of force. One more example. Suppose you place 1 kilogram standard weight on a surface with no friction and pull it with an acceleration of 1 meter per second square. The force applied is called 1 Newton. Now this is we are going to derive the unit of force. Now use your brain power. Acceleration is a vector quantity. Is force a vector quantity too? Now, yes, force is vector quantity because where we apply force, direction plays a very important role. Further, to study more about force and acceleration, let's understand the concept and we'll try this. Place a weight of 1 kilogram on a smooth wooden table. Spread some talcum powder evenly on the table. Now pull the 1 kg weight with an acceleration of 1 meter per second square. Again pull it with an acceleration of 2 meter per second square. It means that now you have applied a force of 2 Newton. You will have to take many trials for this experiment and then we will conclude what is it. Force is measured by the acceleration. We have learned about the relationship between displacement of a body resulting from the force applied to it and the work done. Basically, a body is accelerated only when force is applied. And when force is applied, it is being displaced. That is, there is change in the position. Now look at these examples. David and his friends walk to school. Mary has joined a dance class. The dog walking and people walking. We have learned about the work energy relationship and that the ability to do work is called energy. So using force, mass and acceleration, we come to a new concept, energy. Energy is the ability to do work and that ability is called energy. We will now study the relationship between force, displacement and work. Now consider an example. In the figure, alongside a string attached to a wooden block on a table is passed over a pulley and tied to a weight, as shown in the diagram you can see. On applying sufficient weight, the block will be seen to move. Which force is applied here? Now here the gravitational force pulls the weight downward, which leads to a mechanical force that moves the wooden block. Otherwise the block would not have moved. How can this force be increased? The force can be increased by hanging more weight on the pulley. What will happen on applying more force? When we apply more force, the block will displace more on applying more force. When can we say that work is done by the applied force? If the block moves forward, we can say that it has been displaced. And when displacement takes place, we say that the force has done some work. Can we measure this work? We know that work done depends upon force and the displacement. The amount of force you apply, that much amount there will be displacement. The following formula expresses this relationship. Work done by the force is equal to F applied to the body into displacement of the body that takes place in the direction of force. It takes place in the direction of force. Hence, work done is said to be F into S, where F is the force applied and S is the displacement that takes place in the direction of the force. In the SI system, the unit of work is joule, while the unit of force is Newton and the unit of displacement is meter in SI and MKS. In CGS system, the unit of work is erg. That means the unit of force is dynes and the unit of displacement is centimeter. If a force of 1 Newton parallel to the surface of the table is applied to a wooden block, it is displaced by 1 meter, then it can be said that the force has done 1 joule of work. In this example, the displacement is in the direction of force. I hope I am clear with the relationship between force, displacement and work. Thank you.